Drift velocity. Drift velocity. Here we have a conductor which is connected to a battery, and V be the terminal voltage of the battery, and this is the battery which is connected to the conductor of length L. This is the conductor. V be the potential difference be applied across the two ends of the conductor. Two ends of a conductor of length L. Of a conductor of length L. Name of the conductor is X1, X2. V be the potential difference be applied across the two ends of the conductor X1, X2 by connecting a battery, by using a battery of terminal voltage V, not EMF, it should be terminal voltage. V is the terminal voltage. V is also the terminal voltage of the battery of the same terminal voltage V. Such that the electric field intensity, in this case battery, and X1 and X2 is the conductor and L is the length of the conductor X1, X2. X1 and X2, and field intensity Ex, field intensity Ex from its positive end to negative end, that means towards right. Such that an electric field intensity Ex from the positive end to negative end, that means from the end X1 to X2 of the conductor. Field intensity Ex from positive end X1 to negative end X2. Acts from the end X1 to X2, and X1 is positive end and X2 is negative end of the conductor. We can erase this part of we have to find the expression of drift velocity. The force experienced by a free electron of the conductor is the force experienced by a free electron of the conductor, free electron of the conductor is F equal Q E dot E, charge into field intensity, where QE is the charge of an electron. QE equal minus E equal charge of an electron, which is negative. Charge of the free electron, or charge of an electron. Also, not also, we can write down the expression of force F. Therefore, F equal to E dot E, small e dot capital E. Small e dot capital E, here we did not use a sign of charge of an electron, that is QE was minus E, but here we have to put only the magnitude of charge. QE is minus E, but in the expression of force we cannot use a sign of charge. That's why in place of QE we have to write E only. So we get F as E dot E, small e dot capital E. That is the force experienced by a free electron. Force experienced by a free electron which exists in an electric field of field intensity E. This force acts in the direction, in the opposite direction. This force acts in the opposite direction of field intensity E. This force acts in the opposite direction of field intensity E. Field intensity E. So we can denote the direction of force in the diagram here. This is a free electron, and free electron will be accelerated towards the positive end with drift velocity Vd. And we can denote the direction of force also. Field intensity E acts towards right, but force acts towards left, means force experienced by the electron will act towards the positive end. Force acts towards the positive end of the conductor. Field intensity acts towards the negative end. Therefore, the vector expression of this force is vector F equal to small e minus vector E. Small e bracket opened minus vector E. So therefore, vector F equal to minus small e vector E. There is no dot, no cross between small e and capital E. Vector E acts towards right and vector F acts towards left. Negative sign indicates that force F acts in the opposite direction of field intensity E. This is equation 2. Therefore, the acceleration produced in the free electron is acceleration produced in the free electron is acceleration produced in the free electron is is A equal is given by the acceleration produced in the free electron is given by A equal small a equal F by m. Force by mass is the acceleration, where m is the mass of an electron, where m is the mass of an electron. Mass of an electron. Now putting the expression of f or comma a equal, in place of f we can put e dot e capital E, small e capital E divided by m. So using equation 1. So we get the expression of acceleration produced in the free electron which is drifted towards the positive end of the conductor with a drift velocity Vd. This is the acceleration A equal to E by m, which is equation 3. Equation 3. Therefore, what will be the vector expression? Vector A equal minus E vector E divided by m. Minus E vector E divided by m. Negative sign indicates that acceleration of the free electron will be in the opposite direction of field intensity. So in the diagram, electron will be drifted with a drift velocity Vd, and acceleration acts towards the positive end of the conductor. Acceleration, but field intensity acts towards the negative end, or that's why acceleration A and field intensity E are opposite to each other. So vector A equal minus E vector E by m. That is the vector expression of acceleration produced in the free electron. If Vd is the drift velocity, Vd is the drift velocity, Vd is the drift velocity of the free electron. Vd is the drift velocity with which the free electron is accelerated towards the positive end of the conductor. If Vd is the drift velocity with which the free electron is accelerated towards the positive end x1, positive end x1 of the conductor. x1 is the positive end of the conductor. x1, x2, then A equal Vd by tau. Vd is the drift velocity and tau is the relaxation time. You know that acceleration is change in velocity by interval of time. That's why you have written acceleration A equal Vd by tau, where tau is the relaxation time. Tau is the relaxation time. Tau is the relaxation time for which a free electron, relaxation term for which a free electron accelerates between for which a free electron accelerates before colliding with positive ion of the conductor, before it undergoes a collision, tau is the relaxation time for which a free electron accelerates before it undergoes a collision with the positive ion of the conductor. Positive ion in the conductor undergoes a collision with the positive ion in the conductor. So in the diagram, so we can erase this Vd and E, and electron is accelerated towards positive and with drift velocity, and here we have a positive ion, and this electron will collide with this positive ion. Electron starts to move at t equal to 0, and it collides at the time t equal to tau. At the time t is equal to tau. So interval of time is tau. This is the interval of time in which electron undergoes a collision with the positive ion in the conductor. A is equal to Vd by tau. This is equation 4. Comparing equation 3 and 4, we get, comparing equation 3 and 4, we get Vd by tau equal Ee by m, Ee by m, small e capital E divided by m, or Vd equal to under bracket Ee by m bracket closed into tau, Ee by m into tau, So this is the expression of drift velocity of a free electron with which it is drifted or accelerated towards the positive end of a conductor, to which a potential difference V acts across the two ends of the conductor. Drift velocity of a free electron, not the bound electron. Free electron can be accelerated with drift velocity. So what will be the vector expression of drift velocity? Minus E vector E divided by m. M is the mass of electron, bracket close, into tau. So negative sign indicates that drift velocity and drift velocity is in the opposite direction of field intensity E. What is the order of drift velocity? Vd is of the order of 10 to the power minus 5 meter per second, which is very small velocity. But orbital velocity of a bound electron revolving around the nucleus, V naught is of the order of 10 to the power 6 meter per second. But V0 is of the order of 10 to the power 6 meter per second. So this is the orbital velocity. But Vd is the drift velocity. Orbital velocity of not free electron, it should be an electron or bound electron, an electron bound to the nucleus. And Vd is the drift velocity. Vd is of the order of 10 to the power minus 5 meter per second, but V0 is of the order of 10 to the power plus 6 meter per second. Vd is very small velocity and V0 is very large velocity. And if we consider a diagram, a nucleus around which an electron is revolving with the orbital velocity V0, orbital velocity V0 acts along the tangent, and V0 is of the order of 10 to the power 6 meter per second. This electron revolves around the nucleus. But drift velocity is of the order of 10 to the power minus 5 meter per second. Drift velocity Vd will be accelerated towards the positive end of the conductor. So Vd is of the order of 10 to the power minus 5 meter per second. which is very small velocity with which an electron is accelerated inside a conductor, and orbital velocity V0 is very large velocity. And we have another additional information, that is also what is the order of relaxation time. Tau is of the order of 10 to the power minus 14 second. Relaxation time is also very small time. Tau is of the order of 10 to the power minus 14 second. Relaxation time is the time in which electron undergoes a collision, in which electron will be accelerated before it undergoes a collision with the positive ion of the electron, positive ion of the conductor. And in this case, m is the mass of an electron, which has value 9.1 into 10 to the power minus 31 kg.